Hey, what an amazing moment, all right, to work on a project together. It's really wonderful here. I believe your coding journey is going smoothly, all right. And today we are going to be looking at this project, all right, function pointers, all right, C, the same language, all right. Okay, so once again, please ensure you go through the resources. It's very important you go through the resources. Then uh, look through the project requirement as well, so that you know, we understand. But I believe it's the same like what we've done before now. The previous video, I believe that um, the requirements are same. All right, so look at the general requirements. Okay, so first things first, but I want you to watch to the end, all right, because in this video we are going to be looking at this concept. Then all the questions will be solved, the task questions. We will look at them in this video. Please like and subscribe to this channel. It's very important to keep you abreast with this project and every other thing about programming, web development are covered here. Please subscribe and like this video. All right, I'll move down to look. First, let's look at the quiz questions. Okay, while looking at it, I'll do some explanations here and there so that you will understand why we have what we have. Okay, so to store the address of this function, void new, void, all right, to the variable f of the pointer to a function that does not take any argument and does not return anything. You will do check all the correct answer if there's more that if there are more than one. All right, so this is a function. Okay, this is the function name. Neu is the function name here. All right, if that is a function, then neu okay, just hold on, I'm trying to illustrate this. If that is a function, then neu, this is the function name. All right, this is the function name there. Okay, then for this function you have uh, it's going to return a type void. Okay, this function neu is returning a type void, and you are passing a void, as you are passing a void argument or parameter in this bracket. That means you are passing no argument. That's just the meaning. All right, you are passing no argument, which is void here in this function. Okay, and you are returning void. All right, so here they said to store the address of this function, this, to the variable f of the pointer to the function that does not take any argument and does not return anything, you would do. Okay, so um, this, we do this. All right, and this is correct as well. F equals to neo. Okay, and f is equals to operand. All right, operand neo. All right, that symbol. This is an operand. Ampersand, sorry, ampersand. Sometimes I call it operand. Ampersand, alright? That's that symbol, alright? So this is going to return this. Neo and this, alright? As address to a function. Okay, let me just say this quickly. A function pointer stores the address of some data stored in the computer memory. That's what the function pointer does. And for a pointer, it can point to data. We are used to uh, pointing to variables. we are used to pointing to variables, but I'm telling you that a pointer can also point to data. All right, can point to data, and they can also point to what? To functions. All right, they can also point to functions. Can also point to data as well as function, not just variables. So take note of this. Pointers does all of this. Okay, if you are used to pointing pointers to variable, they also point to data as well as functions. Okay, and if we are pointing to a function, all right, let me do this here. If we are pointing to a function, the syntax the syntax will be, okay, let me do the one you are very familiar with. If we have an integer, a function confunc, all right, then we pass in the argument int a and float b. Okay, this is a function. This is a normal function that you are familiar with. All right, the function name here is func. All right, and this is the argument, and at the end of the day this function is going to return what? Return an integer. This is the function we are familiar with. All right, then if we talk about pointers to function, we are talking about this, just the way it is. I'm just putting repeating that, then I'm going to make changes. So for pointer to function, I'm going to add an asterisk here. That stands for pointer. It's pointed to this what's it called? This argument. Okay. Then that's not all. Okay, I'm going to sorry, let me drop this. Just a second. Yes, this is what I was looking for to explain that. Okay, look at the question here. All right, you see. So again, this function is going to be in a square bracket. All right, so this our function is going to be in a square bracket. All right, please just manage this. So this is a pointer to a function. This is a pointer to a function. All right, so let me clear here. It looks very rough. Okay, so I believe that um, I'm just explaining that first one. I just had to, you know, deviate so that I'll give more information about the others. So looking at question 1, if f is a pointer to a function that takes no parameter and returns an integer, you can call the function pointer by f. This way, okay, they want us to tick the correct way to call this pointer function. Alright, no, this is definitely not this, because you can't call a pointer a function by just calling the using just the parameter. Alright, this is correct. You can call it this way as well as this pointer, point it to it, then you can call it in the usual way you call a function, or you call it using this this asterisk shows pointer to that function. All right, this we are here now. What does a pointer to a function points to? Okay, the first character of the name of the function? No. It points to a data. Pointer to a function points to code and the first byte of the code of the function. So this and this will be the correct options. This void, okay, this is a pointer to an array. All right, is A pointer to a function that takes in int and a float as a parameter and returns nothing. Yes, of course, it takes in int and float and return nothing, but this is with this shows that this is an array. You can see that square bracket there shows that this is an array. So the correct option would be an array of pointers to functions that take in an integer and a float as parameter and returns nothing. How do we know that? Because of this data type void, they are returning what? Void, which is nothing. Which one is a pointer to a function? Which one is a pointer to a function? If you look at this resource, all right, you can see this pointer to function returning an int. All right, so from here I believe you can answer that. You have an integer, all right, then you have this the function name func, all right. This is a pointer to a function. Then we are passing in the parameters or the argument int a, which is an integer, and b, which is what? Float. So that is that. So which one is a pointer to a function? So obviously this would be the correct option. So alright, so look through that. I believe that the explanation I've done will suffice for the questions. Please, if you don't understand other concept, you can drop a question in the description, in the link, in the comment section of this video, or go through the resources. Alright, go through the resources. In case you cannot find answers, you can drop a comment to this video. Okay, so that's that about the quiz. All right, so we are going to move directly to solve the task questions. All right, that's what we are going to be doing now. So here it says write a function that prints a name. So first things first, let me restore this down, split my screen. All right, just got a terminal. Okay, again I'm going to move into this ALS low level programming. I'm going to copy this. I'm going to move it to that GitHub repo by using cd. I'll paste that. Alright, then the next step will be to create this directory. Okay, so I'll go ahead and copy it. So if I do to create a directory like you have already known, we'll do mk dir make directory, then Ctrl V, I'll paste the name of that directory in there. Alright, if I press enter, you see that it cannot make because this is said already exists. It already exists. That means I have it there. So how do I, if I list files and directory, you see that it's already here. So that means I've created it before now. So the best thing to do now would be to cd into it. This is telling me that I have that directory already. So if I press enter, you see I'm now inside this 0 times 0 function pointers. Alright, so that will be that. So the next thing after doing that is going to create a readme file, like you see from the instruction, the requirement here. Alright, so you go ahead and create your readme file. So how do you do that? You're going to use vi and do readme dot md. Alright, do vi and do readme dot md. Okay, so if I go ahead and hit enter, it's going to take me here. So this is the content of my readme. Like I always say, to get this, you just I copy the question's name, the questions here. All right, what is my name? Then the question 0 to the end. All right, that makes the content of my readme. All right, either way you can, if you don't want to do that, you can put this as your readme. All right, just ensure you don't have an empty readme.md file. So wherever you are putting, just put in that. When you are done, you do escape, then colon wq, or just use colon q because I'm not saving. Just quit that. All right, if you do that successfully, that means you have a readme.md file. So after that, the next thing you are going to do now is to start creating your individual files. So the first one we have here is okay, this is the first file we have. All right. Okay. Let me just be sure that if I have my main.h, let me vi. Okay, that's not there. Okay, so the next thing we're going to do here now is to create our individual files. So I'll just go ahead and copy this, the file name here. All right, Control C. I'll come here, I'll do vi. Using vi, I'll do Control AV to paste that in. All right, if I press enter, it's going to bring me here. All right, so this is the content of my read. We are including our function underscore pointers.h. All right, okay. We have that file has to be there. Let me see if okay. All right, let me just go back. I need to we need to that our header file need to be there. So okay, the header file we are talking about is this. Sorry, I just needed to do this video very quickly. All right, you can create your underscore pucha, but it's not really compulsory because they are not going to check that you don't have to even push your underscore pucha. All right, so going to create this function underscore pointers.h. That will be a header file. Sorry, I was too fast. Okay, so just come here, copy this file name, Control C, then come here and do vi, Control AV, you paste that in. All right, if I hit enter, all right, so this is the content of that file. Once again, like we always explain, the prototypes are given in the question, so you can always access the prototypes. Let me close this quiz. Let me hide this quiz. I want to be scrolling up and down before I can get where I want. Okay, so these are the prototype. For tag 0, this is it. So you can see we have that here. So we just copied that prototype from here. So you can do the same. That's for tag 0. Then tags 1, look at the prototype here. All right, just copy that somewhere. So just look through, they are there. Look at this, the prototype. So that is where all of this we are gotten from. Then we include if not def function pointers underscore h, then define if not defined. This if not defined. All right, if and def stands for if not defined, then define function underscore pointers underscore h. Then we are including a standard define.h. all right, then we include our standard library.h. okay, then we added all these prototypes. Then at the end of the day we did end if. So you put this the content of this header file here, then you can now do your escape column wq. all right, then you escape that. After that, you have to be sure that you okay, if you do that rightly, well, you could just check the header file with Betty. Okay, Betty file name. All right, so if you hit enter, all right, that is correct, so no error. So after that, you can now do your git add to push your header file. Git add, you press dots. All right, you press enter. After that, I've done that already. I don't need to push twice. Git commit. -m, your commit message. Of course, that should be the name of the file we are trying to push. All right, which is function underscore pointers.h. After this, you press enter after committing. Then after you do git commit, you can then go ahead and do your git push. Okay, so you hit enter. So after that, the code will be pushed to the remote, and you can go ahead and check your code for tag 0. Okay, for tag 0, check at a new test. Alright, so as you can see, this is all checked correctly. Okay, just a little of following the instructions here and there, you get similar result. Okay, so I'll close this. So the next one will be, if you spend too much time thinking about a thing, you never get it done. Alright, so I'm going to go down, write it. So it says write a function that execute a function given as a parameter on each element of an array. Alright, so we go down here. I'll copy the file name. Okay, using Ctrl C. Then I'll come down here. Let me clear here. So I'll input, I'll do vi Ctrl AV. I'll paste in the file name. If I hit enter, alright, you have this. So this is the function that helps us to write this is a function that executes a function given as a parameter on each element of an array. Alright, so this is the name of our function, array iterator. Then this function is returning void as the type, returning type void, and these are the arguments passed into this function. Alright, so as a requirement here, where size is the size of the array, alright, which was indicated here, an action is a pointer to the function you need to use. So look at it here, a pointer. You see this asterisk, okay, this is a pointer. Alright, at the end of the day, then we indicated that this is an integer. So that's that. So you close that bracket, then you put your curly braces, unsigned it. We are declaring I as an unsigned integer, as the return I as an unsigned integer. And if array is exactly none, or action is exactly none, alright, return. We are returning for I exactly equals 0, I less the size I plus plus. So increment I if I is equal to 0 and is less than size. Then we have action array I, our I here, which is our variable. Alright, so that's that. All of these are documented, these are comments. Alright, so put this into that file. When you are done, you can do your escape column WQ. Alright, so you exit. Then you can go ahead and confirm if you did the right thing by checking with Betty file name. So you paste in the file name. Alright, then you hit enter. So Betty will do checks. Alright, so if you return this without an error, that means you are correct. You can go ahead and do your git add dot, you press enter, then do your git commit -m commit message, you hit enter, then you can then do your git push to the remote. You hit enter. I've done that already, so I don't need to push that twice. So once you are done with that, you can then come here and check your code. Alright, so let me run this check right now. So done. This is all correct. All right, just look through and you get same result. So I'm going to close this while we move to the next task. To help with circumstances, I create opportunities. Write a function that searches for an integer. This is the prototype. Here size is number of elements in the array. CMP is a pointer to the function to be used to compare values, and int underscore index return the index of the first element for which the CMP function does not return 0. If no element matches, return -1. If size is less or equal to 0, return -1. So these are the requirements. So again, we will go ahead and copy the file name. Alright. So I'll copy this file name, Ctrl C. Come back to my terminal, I'll do VI. Ctrl AV, I'll paste that. Alright, so a function that searches for an integer. Alright, this is it. Okay, function name, like we always to return type integer, then this is the parameters. Okay, this is the parameter, and you have some pointers here. So you declare your variable I as an integer, and this is what you have. Alright, this is what you have. So once you have done that, once you are putting this, you do your escape, then column WQ, alright, and hit enter. Escape, column WQ. Just use Q because I'm not saving. Hit enter. You can go ahead and do your Betty file name. It's checking for Betty. Alright, that's correct because Betty did not return any error. That means our code follow the Betty standard and is Betty compliant. So you can then go ahead and do your git add. You hit enter, then do git commit. Commit message, you hit enter, then lastly you push to the remote, git push, you hit enter. So once you've done that, your code will be pushed to the remote repo, and you can come here to check your code. So I'll just run this check. I'll allow that to. Okay, let me start a new test. Let me continue while that keep running. So we'll move to the next one. A goal is not always meant to be reached. It often serves simply as something to aim at. Write a program that performs simple operations. Alright, you're not allowed to use the standard library. Using this, and you can assume num1, num2 are integers, so use this function to convert them. Alright, these are just addition, subtraction, and all that. So I'll come down here to copy the file name. Alright, so for this we are going to be creating all these files. Going to create readme.c, up underscore function.c, then going to create get up underscore function.c and calc.h. So these are the files we are going to be creating. First things first, I'll copy the first one using Ctrl C. I'll come here, I'll do VI, I'll paste that file using Ctrl AV. If I hit enter, alright, I have that code there. Let me do page up so that you can see the. Alright, so we include function underscore pointer.h, which is our header file. Then we are including standard library.h. We are including standard input output.h. Then we include theorycalc.h. Alright, okay, this. Alright, I have this already, so don't worry, we are going to get there. So these are your comments. Alright, then this is your function name, which is main, which returns an integer. Then this is the argument you are passing to this function with an array. Alright, an array. Okay, so quite much though, so you can just look through this page down. Alright, what this function does, this main.c. Main.c should contain your main function only. Alright, you have to use at OI to convert argument to integer. You are not allowed to use any kind of loop. If you are not allowed to use a maximum of 3 if statement. Alright, so we are allowed to use 3 if. So you can look at that. These are 3 ifs, and so to ensure that those requirements are met. Okay, so this is what we have here. Alright, so you can just put this into your code. I'll leave the source code, the document, in the description of this video. Alright, let me do page down. So this is the end of the code. Then we are at the end of the day, we are printing this. We are putting this. Alright, so once you are done with that, you can do your escape, then column WQ to save and quit. I'll just go ahead and quit and hit enter. So after doing that, for that first file, you can go ahead and check for your Betty. So allow Betty run a check. That first file is correct. So you can push it using git add. Alright, dot. Then you hit enter, git commit -m. Okay, then your commit message like this, git commit. I believe you should be familiar with that -m commit message. Of course, you are using the file name. You hit enter, then you can go ahead and do your git push. Alright, once you do this, you push your code to the remote repository. Okay, so once you are done with this, you can now come here and input. We have just created this file. Okay, so we go ahead, we can create this also. So I'll copy this using Ctrl C. So I'll come back here, I'll do VI, Ctrl AV, hit enter. So this is our file 3up_function.c. so we are including calc.h, which is this. All of them believe we have this file. Don't worry, we'll get there, we'll look into the file. Alright, then these are our integers. Okay, alright, here we are declaring our variables. Sorry about that, we are declaring our variables to be this. Okay, let me go through, let's just look through. Yes, theory_ops.c. Okay, yes, of course, they were given here. The file should contain the 5 following functions. not more. Okay. Okay, yeah. This file should contain the following five functions, not more. We will give it here: up underscore add, return the sum of a and b. This is the prototype. Okay. Then you have this. For this is the prototype. So when we have this, you include this prototype here, and you see we return the sum of a and b to return a plus b. That's what that does. Okay, then for the subtract, op underscore sub, which stands for subtract. This is the prototype. All right, that's what we have here. That's what we have here. Okay, so return a minus b. That will return a minus b. Then for this multiplication returns the product of a and b, and this is the prototype. You are going to put that in. Product of this is it, integer a, integer b, return a times b. So after that you have this division. Op underscore div returns the result of the division of a and b. So this is the prototype. Int op underscore div integer a, then integer b, divide. All right. So again you have this modular returns the remainder of the division of a and b. So that's the last one here. So that's just basically what you put in there. You have this series of comments for each of them. Okay, the series of comments for each of them. So once you are done with that, you can do your escape column wq, or just quit. Again, you can check your second file which you created with Betty by running Betty, then the file name. So you run Betty, the file name, to be sure that your code is Betty compliant and is following the Betty documentation style. So I'll hit enter. So you can see all of them, all the functions we created returned safely without any error. So since we have that, you can then go ahead and do your git add dot, press enter, then you do your git commit -m, commit message, you press enter, then you can then do git push to push to the remote. All right, so you press enter. So once you are done, you can go on to create the next file in this particular series. So we are done with these two, so you can come here to create this file. All right, so you do your Ctrl C, I'll clear here. So you do vi, you paste in that Ctrl A V. Okay, you paste in that file name. If I hit enter, talking about swap files. All right, meanwhile the document will be in the link of this the description to this video. You can always pull it out from there. All right, let me just recover this file. All right, okay, I'll leave the document in the link to the description of this video. You get it from there. All right, I believe I'm not pulling the right file. All right, the link to the document, to the complete content of this file will be left in the description. Okay, let me just get out of this term of VI. Don't worry, these things it happens sometimes. Let me just find my way out of here by using adding the exclamation mark to it. Okay, just hold on. Let me just maximize this. Okay, they want me to press enter. Sometimes it can be like this. Don't this shouldn't. I'll get out. Don't. Skip colon. Please don't. It can be like this sometimes. This VI, they can have similar issues. So just hold on. Let me get out of here. Skip colon. Let me just look through this setting. Okay, press enter or type any command to continue. Colon. Sometimes VI can be something else. Either way, let me try this. If it's not working, I'll just quit and create another terminal. Skip colon WQ. Okay, I believe I'm out now. Alright, it can be like that sometimes. You're just trying the same thing. Alright, so the link to that file will be dropped in the description, so you shouldn't bother. That shouldn't bother you at all. So if we do Betty, that file name, you press enter to check for Betty. Okay. Oh, I believe because of the issues just now, let me just clear this quickly. Alright, VI Control V. They're talking about trailing white spaces in where the the 22nd line. cover this file. Alright. Okay, so you can see I left a trailing white space here. You can see, so I'll remove this using my backspace. Alright. Okay, so I've removed that trailing white space. I believe when I was trying to get out of this VI, I left a trailing white space. I use my backspace to remove that. So I'll do escape column WQ. So if I do Betty, let's just check if we still have that error. Okay, line 20. Don't worry, we're going to walk through this. I'll do VI again. Believe it is during the process of hitting those buttons, try to get out. Okay, I'm just checking through this to be sure that I don't have those trailing white spaces. Alright. Okay. Meanwhile, the link, like I said, that document will be dropped in the description to this video. Okay, so let me restore down. So since we have that, you can do that and do your git, do your git add, and the rest git commit and git push. Alright, so the next thing, I'll just quickly move ahead and copy and create this file. Okay, everything you need will be in the document. I don't want this video to be that long. It's quite big, it's becoming long already. So if I do vi for the last file, okay, this one showed correctly, unlike the other file that we were battling with. Alright, so for this, you have you're including these header files, you have your comment. Alright, then this is your function. Okay, this is your function. If you look at the file here, okay, yes, this is it. This file should contain all of the function prototypes and data structure used by the program. Alright, you saw those add all these prototypes. Alright, we repeated all of this here, all of this. Okay, all of these prototypes we also use here. This add, subtract, multiply, they will also use here. Okay, so type def structure, the name of that function will be op, then this a pointer, alright, then you have another pointer which is called f, and you have, this is the argument to this pointer, function, this is a function to a pointer, then this is the argument, passing this argument a and b, which will return both integers. Then you have all of this, okay. Add, to add, these are snippet to add, subtract, multiply, divide, and get the modular. So you put this into that file. Alright, after that you can do your escape, column WQ. Right, I'll just quit with Q. Okay, do your escape, column quit. Oh, let me hold on. Okay, my internet connections. Oh, sorry about that. Just discovered that my internet disconnected. Okay, I think I'm connected back now. Escape, column Q. Alright, okay, so I'm out of there. So let me clear this to pull this up. Okay, so after doing that, you can check for Betty for that file, which is calc.h. Alright, so if I do that, alright, so this is correct. It's returned, it didn't return any error, so you cannot do your git add. You can go ahead and do your git add. Oh, I don't know why my internet is flipping off and on. I don't know why I'm experiencing that. Just hold on. Please patient, let me connect back to the internet. Okay, I think I'm back now. So I knew that this is going to. Alright, just quickly let me create that. Let me get another word term. We're almost done with this. I never said the video is becoming quite long, but that's okay anyway, provided we're able to achieve this project. That would be the joy. So cd into ALS low level. So I'll copy this, paste that in, then we go into this directory. I'll copy the name, so I'll do cd, paste that in. Alright, okay, so since we have believe we have added git add, we have done that for that other file. So git push for the last file, which is calc.h. So the next thing is to push to the remote. Once you hit enter, to push that code to the remote repo. So after that, you can now come here. After putting in all of this, I believe we have created all this file. So you can, we have done as well done Betty for them. So after that, you can come here and you run your check. Alright, so you see the code is checked, it's all correct. So last but not the least is to create this file. Alright, the question says, most hackers are young because young people tend to be adaptable. As long as you remain adaptable, you can always be a good hacker. Write a program that prints the ops code of its own main function. This, so they gave you okay up up opcode opkey. This is just a document to read through to know more about that. Okay, so don't have that time, you can look through that. Alright, so I'll copy the file name, I'll come here and do vi Ctrl AV. So this is it. Like I said, the document will be left in the link. Alright, do page down, this is the end of the file. Alright, so once you are done, you do your escape column WQ, then you can run your Betty file name. So Betty is correct, so you can now do your git add dot, you press enter, and after that you do your git commit your commit message, you press enter, then you can do your git push. So you press enter. Once you are done with that, then you can go ahead to check your code. Alright, so once you do that, it will all be ticked like we got here. Okay, so looking at this project, function pointers, I believe is so interesting. Try as much as possible to read more through the resources provided here. Always read more.